The goal of this course is to introduce algorithms that enable machines to learn. This is an exciting new topic and in fact a new and powerful paradigm. In contrast, when we look at most of computer science, the programmers have to specify by hand a set of instructions that spell out what the computer needs to do at every step in order to achieve a task. Now, this is quite challenging, and in fact, the programmer has to know ahead of time what is the solution before he or she starts programming. For some tasks, like if we consider computer vision, where we would like to identify what are some objects in an image, it is actually very challenging to specify some instructions by hand to achieve that. In fact, researchers have tried to do this for a long time and were never really successful just by specifying instructions by hand. In contrast, with machine learning, what we can do is give the computer a bunch of examples. These would be pairs of inputs and outputs. So for example, images as inputs and then classes of objects as output. And then the computer will learn to automatically figure out what are the instructions it needs to execute in order to map the inputs to the outputs. So in other words, machine learning is this new paradigm where we give the computer a bunch of examples and then we program it to essentially learn what are the right instructions to execute in order to complete a task that produces the desirable outputs. So this is quite successful in many difficult applications. They include, for instance, natural language processing, information retrieval, data mining, computer vision, robotics, and many others. For this course, we're going to cover the basics of machine learning. So this is really just an intro course. But if you're interested, there is another course, which is CS485/685 that talks about the theory. So this course is really an introduction. It's more on the practical side. So we're going to talk about algorithms and we're going to see how they get applied. So the objectives of the course are going to be to formalize a task as a machine learning problem. Then we're going to identify some suitable algorithms and apply them to different machine learning problems. And finally, we're going to apply these machine learning algorithms to large data sets. In terms of the topics, we're going to cover in this course several interesting algorithms, but first we're going to talk about some basic notions like generalization from examples to some rules. Then we'll talk about underfitting and overfitting, which are challenges for machine learning techniques, and cross-validation. After that, we'll get into models. The first type of model will be the simplest. These are linear models because they're based on linear algebra. So we'll talk about linear regression as well as classification with linear separators. Then we'll get into nonlinear models. These are going to include nonlinear basis functions, kernel methods, and also deep neural networks. So we're going to spend quite a bit of time on deep neural networks. These will include convolutional neural networks, autoencoders, as well as generative adversarial networks. After that, we'll talk about probabilistic models. Here, the idea is that instead of having a program that essentially maps inputs to outputs, we're going to map inputs to a distribution over outputs. So this is going to be quite interesting whenever we want to express a confidence in the output or whenever we're not sure what the output should be. Among the probabilistic model, we're going to talk about sum product networks, variational encoders, and also normalizing flows. Now, everything I've talked about so far is really within the realm of what is known as supervised learning, but we'll also talk a little bit about unsupervised learning, which includes clustering. After that, we'll talk about sequence learning, which is how we can deal with data sequences. So for instance, if we have a sentence, which is a sequence of words, or a time series, then we'll see some algorithms that are suitable for this. We'll start with hidden Markov models, which are quite classic. Then we'll talk about recurrent neural networks and encoder-decoder models that are more recent. And finally, very recently, we'll talk about transformer networks and attention. There are many techniques that can be used often to tackle the same problem, and it's not always obvious which one to use. So it turns out that it's often a good idea to combine several techniques together, and we'll see ensemble learning, which is a formalism that allows us to do that. So in particular, we'll talk about bagging and boosting. So finally, we're going to conclude the course by talking about large-scale learning and how to do this in a distributed fashion, and also how to deal with stream learning.